consent forms, because those who have not, ATAL has asked us to remove from the list and communicate all information only to those who have given the consent forms. Please let me know if you have not completed it. I will share again in the WhatsApp group if you have not completed it. Thank you. Welcome, Dr. Tushar.
Thank you very much, ma'am.
To see you, sir.
Yeah, thank you very much. Nice to see you here.
My name is Vijaya. We have not met.
Yeah. Just we are meeting in the online. So very nice to meet you. Yes,
sir.
yes.
Can you switch on your video so that
Yes.
us can see? There he is. Good afternoon, everybody. Today's afternoon session is led by Dr. Tushar. Sir, if you don't mind, I call everybody by first name. It's a
yes, please. No problem.
Dr. Tushar Kanti Bera is an assistant professor from Department of Electrical Engineering from NIT Durgapur. He has kindly offered to present in our program on electrical impedance-based structural health monitoring of civil structures. His work on electrical impedance tomography and electrical impedance spectrography has spanned for almost 15 years. Both these technologies, EIT and EIS, are safe, non-invasive, portable, low-cost and fast technologies used frequently for health monitoring. And he wants to show us how to monitor structural health using these two technologies. He will show us a lot more examples. He will discuss the technical details of EIS and EIT techniques and their applications to detect the defects, damages, and degradation of civil structures. And he has done extensive work in his doctoral as well as postdoctoral. The electrical impedance technology is used a lot more in probably more awareness is there in the health field, whereas it can be used both as for electrical, biological, and each of them have their own electrical impedance. So I request sir to take over and then share his screen.
Yes. So my screen is visible?
Yes, sir.
Okay. Make it to full screen. Thank you, Professor, for introducing me. And I'm very much pleased to be a part of this FDP. I'm from a little bit different background. I'm from electrical engineering background. But nowadays the research is going towards the multidisciplinary field. So we are working together and we are sharing our knowledge and coming from different expertise from different fields. We are applying together and we are getting some new technology. So electrical impedance tomography is one kind of tool. That tool can be some sound is coming.
Can't hear you. hear you.
Hello.
Yes, sir.
Okay, okay. So yes. So the electrical impedance tomography was developed for medical imaging, and then it has been utilized in several domains. So today I am going to discuss about the technique, how that can be utilized in the civil engineering domain, and what type of characterization can be made utilizing the tool. So outline, I will introduce or I will start with the electrical impedance, because most of the participants may be from the civil background or other backgrounds. So I will discuss about the impedance, electrical impedance spectroscopy, impedance tomography. There are several impedance techniques, but I will majorly discuss about the EIS and EIT. So I will try my level best to make it easy to understand, because this field may be a little different, because it is there will be some electronic circuit and electrical principles will be there. So after that, I will discuss very briefly how the techniques can be utilized for medical or biological or say food technology, and then I will come to the civil structure analysis and EIS for composites also I will discuss, and then I will conclude my talk. So we know that there are several electrical components. In some components, they have the capability of delivering power. So which can deliver the power? That can be considered as source, like a battery. If battery is connected to a load like resistor or any electrical conductor, it will send some electrical current. So these are the very basics of electrical. Then there will be load, as I told, that some wires which can absorb some electrical power, that can be considered as electrical load. There are several other loads like resistor, capacitor, inductors, and so many. And signals, whenever we will have some electrical power, that power can be delivered with the form of electrical signals. So if any source is there, electrical source, and if any load is connected, the source will deliver some electrical power in the form of electrical voltage and current. And those voltage and currents are time varying signals, and that those may be either DC or AC. DC means it will not be changing the polarity with respect to time. So this type of DC is called pulsating or ripple DC, means it's changing in amplitude, but it is not crossing or it is not going in the negative axis of say polarity or amplitude. So these signals are having the DC in nature, but that is some ripple. And if the current signal or voltage signal is straight line with respect to time, so these are called pure DC, which is generally obtained from the battery. But if the signal is varying in amplitude in such a way that it is also going down the time axis, that is going towards the negative amplitude axis, so it's changing its polarity also. That type of signals are called alternating in nature. Or polarity is alternating, so that's why it is called as alternating signals. It may be current and voltage and power. So these are the basics about some thing, and why DC is called direct current or the direct DC voltage or DC current, because the flow of electrons is performed in a particular direction. Depending on the potential available in the battery, the electrons will flow in a particular direction. So it is flowing to the lamp's filament, and due to the ohmic heating, the lamp's filament will be very bright and it will be giving some light. So that is the principle of any light production with the help of electricity. And here it is shown as DC electricity, and the voltage or current form will be straight line with respect to time, because the battery is connected. So pure DC we are obtaining. In case of AC, the signal is changing with respect to time. It is not only changing in amplitude, it is changing in its polarity also with a particular time. So it's changing periodically. That's why these signals are called periodic signals. And generally those signals are generated in power plant in such a way that signals will be in form of sine wave. So sinusoidal waves will be generated. Voltage will be sine wave, current will be also sine wave. And if the material is resistive, there will be no phase displacement. If the material has some property of capacitive or inductive in nature, definitely there will be phase displacement. I will explain the phase very briefly. So here the AC current is explained. The AC current means their current will be flowing through the lamp due to the flow of electrons, and in the circuit electron flow will change their direction. Sometimes it will come out from one part and then it will again entering to that part. So it will be changing in a periodic manner. So that's why this type of signals are called alternating in nature, because they are alternating their polarity. As also amplitude is also changing. So sine wave will be the waveform by which you can represent any alternating voltage or current. Now I will come to the phase displacement. Phase displacement means this is the difference between voltage and current in a circuit in a time axis. This is similar to a phenomena which is, say, if there are siblings for any person, then the birth time will be different, say 1 year or 2 years or several years. So that type of things will be there. So the elder brother will be leading in time and younger brother will be lagging behind the elder brother because he came in the earth some few years later. So kind of depending on the generation of the signal generation time, we can tell that some voltage is leading over the current. That means the voltage is generated fast and then the current started generating, and that's why current will be said as it will be lagging behind the voltage. So if resistor is there in a circuit, voltage and current will be at the same phase. It can be compared with the twin brothers, they came at the same time. And for the inductance, current will be lagging behind the voltage, voltage will be leading, voltage will be generated long back, and after some time, so it may be generating somewhere here, and after some times the current will start generating. In capacitor it will be different, it will be opposite to the inductor. So voltage will be generated after some time, so current will be leading and voltage will be lagging. In the phasor diagram also we can consider by applying some conventions. So there will be 90-degree phase displacement between current and voltage in case of the inductor and in case of capacitor also, but there will be phase displacement of 0 angle in the case of resistor, and this 90-degree will be positive or negative depending on the parameter whatever is there, either inductor or capacitor. Okay. So if there are the combination of those 2 or 3 elements, then the angle will not be pure 90-degree. If it is pure inductor or capacitor, the displacement will be exactly 90-degree. If there are some composition or combination, definitely there will be less than that. And if they are connected together, all three are there, so definitely there will be also some different circuit, like they may be connected in series or they may be connected in parallel. So depending on the combination, there will be some the property created by capacitive component, that is called capacitive reactance, and then there will be some inductive component, that is called inductive reactance, denoted by XL and XC, and there will be resistive component. And depending on those parameters, the dominating property will be giving either the voltage will be leading or the current will be leading. That means if the circuit will be called as inductive circuit overall, or it will be called as overall capacitive circuit. Okay, so these are already explained: resistance, capacitance and all connected in series. This is also explained. Now total impedance will be by this formula, so no need to remember. I am just giving some refreshing kind of, so that we can understand the principle of impedance of in the slides of spectroscopy and tomography. So here we can see that the capacitive reactance and inductive reactance both are function of frequency, because capacitive reactance amplitude is 1 by omega c, and the inductive reactance is omega L. So omega is 2 pi f, where f is the frequency. So omega is 2 pi f, f is the frequency, and capacitive reactance is 1 by omega c, and XL, that is inductive reactance, is omega L. So here you can see that everywhere the frequency is there. So that means if we have some capacitor and if we are giving some alternating current, the reactance will not only depend on the value of the capacitance but also the value of the frequency, means at which frequency current is flowing. So definitely this will be a function of capacitance and function of frequency. Similarly for the inductance also, it will be a function of inductance as well as function of frequency. For the resistance, it will be frequency independent, because for this resistance, the impedance of a resistor, pure resistor, will be resistance itself. So some other circuits by which you can get the idea of leading and lagging and how those signals are generated with a time displacement in the time axis. And as I explained that it can be considered by two runners also. Some runners will be ahead of some others. So this runner will be called as leading in time phase, and this will be called as it is lagging behind that the green runner. So if that runner is considered voltage, and if this is called as is assumed as the current, then we will tell that in this circuit current is leading over the voltage and voltage is lagging behind the current. So current is leading here in case of capacitive circuit, and current is lagging here in case of inductive circuit. So like that we can understand and we can compare. Now the measurement of impedance and impedance of any material. So for measuring the impedance, there are several techniques, but simply if we have any conductor or any block of material, and if we want to measure the impedance, then simply you can excite that material with some electrical signal, and that signal must be AC in nature, because impedance is the property of the response created by the material in response to the application of the AC signal. So that's why we need to apply the AC signal, and with the help of some conducting material, maybe electrodes or any conductors, and applying the Ohm's law, we can get the resistance of a material for DC circuit. Similarly, for the AC circuit, we can write our voltage developed due to the current I will be V equal to IZ. IZ means the Z will be the impedance and I is the current, V is the voltage developed due to that current application. Now if we apply voltage signal, current will be developed, and for that also same principle will act. So now if we have some unknown object, we don't know about the impedance profile. So if we inject some current with denoted by the red sinusoid wave, there will be some voltage generated here, and that voltage can be obtained either by multimeter or by oscilloscope. So that voltage will have some amplitude. So now for the current injection and voltage measurement, Z is calculated by Ohm's law. So now if the V is the function of say omega, that is a sinusoidal signal, or I is the function of sinusoidal signal. So definitely any one can be taken as reference. In this equation I have taken current as the reference because I am injecting current. So current signal alternating in nature, or AC current signal, can be represented by the Im sin omega t, and utilizing the concept of leading and lagging. We don't know what material is there. We can write simply plus minus. If it is leading, the plus sign will be there. If it is lagging, minus sign will be there, and automatically we will get some voltage, and that voltage will be measured by the proper measuring device, and we can divide that and we can get the impedance with that its phase angle. So there will be impedance amplitude as well as impedance phase angle. So that can be measured by our ammeter voltmeter method or any other suitable impedance measuring device like LCR meter or impedance analyzer, which are commercially available. Now the impedance measurement can be made by instruments, and that instrument may be obtained from our laboratory or it can be purchased from the as a commercial devices. Now for measuring the impedance can be found as true probe method or 4-probe method. So that this is the these are coming just with the connection of probes. So how the probes are connected, how many probes are used, depending on that we can get two type of measurement techniques. So if we inject current and measure voltage with the help of two electrodes only, means we are using these electrodes for current measurement, current injection, as well as we are measuring the voltage using those two electrodes only, then it will be called as 2-probe method. So for this type of material measurement, there will be some contact impedance problem, and that contact impedance problem will give some error. But if the contact impedance is very less for any particular measurement setup, then this method will have some sufficient accuracy. So where the 4-probe method is not possible to apply, or if there is some very less contact impedance, then we can apply 2-probe method. Otherwise, in many cases where the contact impedance are found significant in amplitude, so for reducing the error, we apply 4-probe method. In case of 4-probe method, there will be 4 electrodes, 2 electrodes for current injection and other 2 electrodes for voltage measurement, and this method will be accurate and free from contact impedance errors. So this is the schematic of an impedance analyzer. Impedance analyzer will have 4 probes, 2 for current injection and 2 for voltage measurement, and there will be several knobs to set the current amplitude, current signal waveform, and frequency points, and how the frequencies will be, how the measurements will be plotted, either in a graph or in a tabular form. So everything can be set, and we can perform that impedance measurement either at a particular frequency or in several frequency by automatic frequency sweeping. So that type of facilities are generally there in impedance analyzer, and we can perform the impedance spectroscopy by injecting current with different frequencies. So we will inject current first at frequency 1, so F1, and then we can get the impedance Z1 and phase angle θ1. After that F2, so frequency will be F2, then impedance will be Z2, and theta will be considered as θ2. So like that we will get all the impedance values and associated phase angles at all the frequency points, and we can tabulate that. You can arrange it in tabular form, and from the phase angle and theta we can calculate the real part and imaginary part, that is denoted by R and X. So please don't confuse that this is not the pure resistance always, this is real part of the impedance, so that may be also frequency dependent. In general, if there is any component which is similar to capacitance and inductance, so for that cases the R will be the real part of the impedance, it is not the resistance. So this will be also frequency dependent, and this X will be definitely frequency dependent. Now by this formula we can calculate the real part and imaginary part of the impedance, and in impedance spectroscopy, the real part and imaginary part are plotted along the x-axis and y-axis. So we can get some plot which is called the Nyquist plot, and that Nyquist plot will be utilized for getting the equivalent circuit parameter of this material. So unknown material will be there, you can do the frequency sweep and conduct the electrical impedance spectroscopy measurement, and after that we will get several sets of impedance and phase angles. From there we will calculate the real part of impedance and imaginary part of impedance, and after that we will be plotting the real part and imaginary part, where we will get one semicircular or similar to that type of arcs. There may be several semicircular arcs depending on the material property, and with the established theories and equations and the principle of EIS, we can get the equivalent circuit, equivalent electrical circuit of this material. If that is a concrete structure or brick wall, we can also represent that brick wall with a particular electrical circuit, and utilizing that we can analyze the performance or quality of the wall. Suppose if there is any crack, there will be more capacitance, there will be air, so there will be more capacitance, and accordingly the frequency response will be changed, which will be monitored or which will be possible to be monitored in the impedance studies. Okay, so I have already explained that. So for the biological material, there are several diseases which are dependent on the tissue structure and tissue composition, and depending on the tissue structure and tissue composition, the impedance response changes. So if we have this healthy tissue response already obtained in our literature survey, or if we have any standard chart, and after that if we have some abnormal impedance, and we can go for some detection procedure or analysis procedure, so that we can extract some information regarding some diseases. So this technique is also utilized for detecting the say impedance based biopsy techniques for detecting the cancer cells. So if the cancer tissues are available, and if we put the cancerous tissue across 2 electrodes or 4 electrodes, we will be able to detect some different information which will be related to the cancer or any other diseases. So that type of techniques are utilized in medical field also. And if any tissue is there, that tissue will also have different type of equivalent circuits. So for the establishment of the electrical theories or electrical procedures, electrical impedance procedures for detecting the health or tissue physiology or tissue anatomy, that type of interaction, the interaction between electricity and tissue, that thought came in the mind of Luigi Galvani long back when he was experimenting with the frog legs with some electrical circuits, and when he obtained the twitching of leg muscle, he realized that there is some interaction or there is some relation between the response of the tissue and the behavior of the electrical current. And after that, Professor William Einthoven, who thought that the electricity which is generated by the heart could be detected by some electrical circuit or some electrodes. So he invented or developed his first electrical electrocardiograph machine, that is ECG machine, and that ECG machine was having 3 electrodes in very basic form. So this was 3 tanks filled with the salt water, where he has put his 2 hands and 1 leg, that is left leg, in the other salt water tank. Those 2 salt water container was working as the basics of 3 electrodes, which could be found as the ECG electrode nowadays, which is very compact and AGCL electrodes. But at that time, he realized that there should be some sensors which will be utilized for detecting the electricity generated by the body parts, which is called heart. So since then the interaction of electricity and the body tissue was developed, and after that several theories have been established. So many studies have been conducted by researchers and scientists. So now how the body will have some electrical impedance, because for electrical impedance there must have some capacitive or inductive properties. So from which part of the body that capacitive characteristics or capacitive property is coming out. So whenever we will think about our body structure, we know that body is developed with several muscle tissues, and the muscles or tissues are developed with several number of cells. So the animal body is developed with animal cells, and plants body parts are developed with plant cells. So there are several structures of the tissues, but the cell of a particular species are almost similar. So different types of cells are there, because animal cell and plant cells, some other microbes are also there who have their different distinguished structure of cell. So for animal cell, we found that there are the cell membrane which has the cell sap inside it, so enclosed it. So whenever we look into the structure of the any plant cell, we will find extra component that is called cell wall. So, and some other component inside also, like vacuole and the chloroplast. So there, I don't want to go into much detail in the biology. So for a biological cell, if we have a particular tissue, as I told that if the tissue is kept inside 2 electrodes or 4 electrodes, we can get the impedance. So how the impedance is coming, from which, what is the origin for that? So if we have a particular cell, and if we cut that cell and put in under the microscope, if we are able to see the structure of the cell membrane, we will see that cell membrane is developed by protein, lipid, protein bilayer, and this protein is the hydrophilic, so it is water loving. It contains a lot of water inside it, and similarly other protein layers also working as a similar. It having so lot of water, and that's why they are conducting in nature, because water will be there means there will be that material will be conductive in nature, and the inner material or the middle layer is developed with the fat. So lipid is the fat, and oil. So definitely oil is an insulator. So we will definitely think that there are 2 conducting material which are sandwiching one insulating material. So from there the capacitor structure is developed, and automatically we will get some capacitance from this cell membrane. So each cell will have its own capacitance called cell membrane capacitance, denoted by CCM. There will be some other ionic solution, salt solution, like resistance will be created by intercellular fluid. Intercellular fluid means which is enclosed within the cell membrane, and extracellular fluid means which will be enclosed, which will be there in between 2 cells or other cells. So this is intracellular fluid, and this is extracellular fluid. So within this extracellular fluid, all the cells will be suspended in 3D array, and the tissue will be developed. So if we take one isolated cell, or if you model it, and if we assume that one electricity is injected, then the electricity may have 2 paths, one through the cell and other through the cell sap or the the extracellular fluid. Now we injected the current will be divided in two paths. Now the current is dividing in two paths means there will be the parallel circuit. So for this type of cells, the capacitance will be developed by the cell membrane. So we put some cell capacitance CCM, and then there will be resistance inside the cytoplasm or intercellular fluid. So there will be a RICF, and also for extracellular fluid there will be another resistance, so RECF. So automatically if the current passes through this, so this current and that current passing through this resistor will be same. In series circuit the current is same, so that's why they will be connected in series, but this current will be differ from that current. So definitely the current differs in the parallel circuit, so they will be connected in parallel. So automatically we will get that type of circuit as a standard electrical equivalent circuit model for one isolated cell. So for plant cell also I will just keep very quickly. So only another parallel circuit if the frequency is increased, the uh, uh, the 1 by omega c will be less because frequency is increased. So this denominator will be very high, so that value will be less. And if that value is less, so automatically there will be some current. So current will be able to passing through the or penetrating the cells. So utilizing that those type of techniques, there are several body composition analyzing techniques, which is called bioelectrical impedance analysis, which are used to detect the body composition in our human body. Sometimes fruit juice or fruits or foods are detected with the help of impedance analysis. Even the cell detection, cell damage detection is also done by the help of impedance studies. So if the cells are damaged, then definitely there will be some impedance change, and that can be monitored by impedance measurement. So simulation studies can be also done by developing some cell model, and we can simulate some electrical current, and you can see how the current path is changing with the frequency. So with the higher frequency, you can say that at lower frequency, you can see that currents are very few currents are passing through the cell, and at higher frequency, you cannot see even the cell also. It is seeing almost the homogeneous medium. So the cell membrane reactance becomes very less. So current can pass easily through the cell also, cell and extracellular fluid. And for different cell structure and different the porosity of the cell membranes, we can find the different current paths in console. So these studies are done as a basic studies for understanding the current conduction path, which is dependent on the frequency. Now, depending on the principle, the electrical impedance analysis technique can be developed, as I explained, which will be having two electrodes. Two can be pasted on the hand and two can be pasted on the foot. And the patient will be lying on a bed, and the current will be injected as a very small amplitude, 1 milliampere or even less sinusoidal current. Frequency may be 50 kilohertz, because for human being it is understood that 50 kilohertz frequency is the optimum frequency. In many cases, in many impedance based studies, 50 kilohertz is followed by the literatures. So that frequency can be injected, and we can measure the impedance. And changing the frequency also, we can get the information so that we can calculate the body composition. So some instruments are also available with different frequencies, like say it will inject for 10 kilohertz, then it will measure at 500 kilohertz also. So that type of frequency can be utilized for measuring the body composition, like body fat, body water, and those parameters will be also helpful for detecting several number of diseases. Another technique, impedance plethysmography, which will be utilized for measuring the blood volume, which are changing through a limb, because blood is being pumped by the heart. So it is coming to the limbs through the artery and going back to the heart again through the veins. So that type of blood flow measurement is suitable for detecting deep vein thrombosis detection. Deep vein thrombosis is one kind of thrombosis where the blood is clotted in a vein which is deep inside the body, and that blockage of the vein will not allow the blood to return back to the heart. So the limb will getting blood pumped by the heart, so it will be entering to the limb, but it will not be able to return from that. So limb will be swelled and there will be some reddish color, and it will be very painful. And sometimes if it is not detected, the thrombus may be broken due to the excessive blood pressure, and that may spread it over the body, and any other vital organ may be damaged due to the blockage of the artery or vein again. So this should be detected by this type of techniques. There are several other techniques also, but this is a non-invasive technique by which we can detect from the outside. Similar technique is used for transthoracic blood volume detection, which is called electrical impedance cardiography. Utilizing the electrical current, we can get the impedance of the chest, and that will be varying with time because blood pumping is continuously happening periodically. So we will be having some impedance variation, and that variation can be correlated with ECG, and using some formula proposed by scientists, we can calculate the cardiac output, which is the amount of the blood pumped by the heart. So that will be also reveal several cardiac information, and a number of other hemodynamic parameter can be detected. So impedance spectroscopy I have already explained, so it is no need to explain again. So there will be several body composition analysis technique like BIA. Then this is the different thrombosis leg. You can easily understand what is the difference between that. And even for minute study, if we carefully study it, we can detect the blockage area also. For impedance imaging also it is possible, which is called EIT. So utilizing the EIT also it is possible to do that. I have already explained that. Okay, so there will be several theories, so I will skip that. So how the circular path is coming, and depending on the circuit combination, the arc will come. If the inductor is there, then the arc will be in the positive axis, and there is capacitor, and there will be in the negative axis. And if there is any resistor in connected in series, so the starting point of the arc will be away from the zero, but if there is no series resistance, it will start from the zero. So these are the theories. If there are two parallel circuits connected in series, there will be two semicircular arc, and depending on the value of the capacitance, the curvature value of the capacitance and resistance, the dimension of the arc will be there. So from this type of graph, we can analyze and we can calculate the circuit parameters to develop the equivalent circuits.
Dr. Tushar?
Yes.
Sorry to disrupt you. Could you please move forward towards the structural member analysis, because the participants are all structural engineers, civil engineers, architects,
Okay.
MTech and PhD scholars in civil engineering mostly. So the health monitoring of structural members is what they are looking forward to. If you don't mind, could you please?
Okay. I will go to that.
Yeah, thank you.
Okay. So I will skip those slides. So in biomedical field, some materials or vegetables can be also detected. The freshness and some analyzing techniques where in which we have worked utilizing the lab view. So these are the techniques how the impedance values can be calculated from the arcs. So utilizing the software called LabVIEW, we can develop some tools for analyzing the impedance parameters. So I will skip that. Okay, these are the techniques where the fruits or vegetables are studied. Several fruits can be studied for ripening and all. All are so health measurement, juice quality, fish quality, and milk quality or meat quality. These are all food technology. For the battery also, for the lithium-ion batteries, which is very useful battery nowadays in our recent time. So that type of materials can be detected, the life of the battery and how the battery is performing, that can be detected by the impedance studies. Now, for the concrete structure, the electrical impedance spectroscopy has become a very popular method in biomedical and other material characterization technique in the MEMS based techniques also. So where the microstructure are also possible to be detected. So for concrete, I will tell that the concrete material is developed with cement, stones, and the other material. So whenever there is two different materials coming side by side, so there will be a barrier. So this barrier will create some capacitive effect. So definitely there will be the difference between conductivity. So conductivity or resistivity will be changed for sands, it will be changed for concrete, and it will be changed for cement. And if it is properly developed and any structure is there, so there will not be any void. But if lot of void is there or any honeycomb is created, then that type of structure will also influence the impedance reading. So for the concept, the impedance was studied first with some impedance studies conducted on the concrete structure or RCC structure, and after that with the help of some X-ray or any other ultrasound based techniques, that was validated, and it is found that the material property or material structure is possible to be understood by impedance studies, and the results which are found from the impedance studies are possible to be correlated with the other established methods, like say any eddy current technique or any ultrasound technique or X-ray based techniques. So the corrosion also can be detected by that type of technique, and due to the corrosion of the iron rod, the conductivity is changed because the material which is developed, that will not be very conducting compared to the solid irons or pure irons. So that type of things are also found. So whenever we are getting some kind of change in the resistivity, that is increasing in nature, and we can found that there may be some other material on the iron or any other metallic part. So after studying that, whenever we have some other gold method or any conventional method, that type of methods also can be studied and helpful for calibrating the impedance methods. So for other techniques, PV cells are also possible. Photovoltaic cells, these are a very emerging field where a lot of energy is developed nowadays, and people are working with a lot of enthusiasm and a very promising and emerging area. So we have to develop the PV cell with higher efficiency. Higher efficiency means the efficiency whatever is there around 15 to 20%, that should be enhanced so that we can utilize a lot of PV cells and we can get lot of energy we can harvest from the sun. So depending on the material and material structure, whenever we are going for any manufacturing or fabrication, there will be several parameters. Say that parameters will be defining the amount of the efficiency which will be exerted in the real time application. So that type of parameters can be detected by the help of impedance analysis. So I will not go through all this literature survey for the PV cell analysis. I will. So yes. So impedance spectroscopy to characterize the pore structure during the hardening process of Portland cement. That type of study they have studied from 10 kilohertz to 15 megahertz, because they told that the frequency whatever is utilized for biomedical application, that is kept in kilohertz, because whenever the frequency is increased, there may be the chance of the skin burning. But whenever we are utilizing some inert material, there will be no such say restriction will be there. And also if we have a higher frequency, there will be the possibility of getting more information because we will scanning a material with a wide range of frequency. So definitely we will be getting some more information. And they also studied the cold plot, and they found some results, and they detected some electrical behavior, that is capacitive circuit and the capacitive circuit similar to the cell or tissue structure whatever is studied in biomedical. So, and also they found that the impedance, the real part and imaginary parts which are varying over the frequency, it is also performed in the place of the concrete structure also. Now if there are the pores or voids are there, and definitely that will be also reflected in the circuit, because in equivalent circuit, each equivalent circuit will have some different composition, say significance. So definitely there will be the influence in the electrical circuit. So we, after analyzing that part of the curve, this is not a complete curve because they started from 10 say several kilohertz, and after that they stopped to the 10 megahertz. So during that part also, this part of the curvature also is possible to be fitted in the circuit analyzing software, whatever I have just skipped the slides. So from that technique we can get the information from the cold plot. So again, for the studying of the carbonation behavior of the cement mortar by electrochemical impedance spectroscopy, this is also another publication. And they told that a new electrochemical method means that time they are telling that it's new, but it is not new. It is new for the civil engineering method, but it was established method for the biomedical application. And they found that the carbonation process can be quantitatively assessed by a parameter which can be obtained by the means of the electrochemical impedance spectroscopy based electrochemical model. And other paper we can tell that they are studying the pore structure, and that pore structure will be evaluated by the cementitious material by electrical methods. And that electrical method, they are also measuring the electrical resistance and impedance both for this study. And here they are telling that there may be some continuous pore, so there may be some pores who will be joined together, and that may be extended from one side to the other side. So the entire pore may be there. So now if we put the electrodes from here to here, there will be some other response, and if we put the electrode across this layer to here, there will be the other response. So in that type of situation, the electrical impedance tomography will be more suitable for detecting the entire response, so that we can get the image of the cross section. So I will be spending few number of slides for explaining the tomography, so that we can get the more information. Electrical impedance spectroscopy will be telling about the measurement techniques, signal measurement techniques, and that signal measurement techniques will be giving us only a few data points. Means we will have some voltage or current or impedance at a particular value of frequencies. Means those will be values either 5 or 6 or 7, and that can be plotted in a graph, that is true. So from there we can get the equivalent circuit also, but it will not be giving us any cross sectional image. So if there is any crack or void, that will be only visible if we have some impedance tomography. Some other techniques are also developed by some other researchers. They studied the 2-point and 4-probe method, and they used the same Weiner technique. Weiner technique is the 4-probe technique, what I have explained in the slides of 2-probe technique and 4-probe technique. And they found that the electrode will have its own impedance, and the cement based material will have its own capacitance and resistance circuit, similar to this parallel circuit which is found by biological materials. So there will be the capacitive response also for cementitious material, and there will be also in series circuit which will be keeping the curve away from the center. So whenever we will get that type of curve, we will be able to analyzing the material. Now if the cementitious component has again some other components like void or crack, definitely the structure will be changed. And definitely with the help of some other techniques, whenever we will have some standard method, we can compare and we can confirm about our diagnosis. So some material with the say fiber reinforced structure can be put in the material studying machine, like say tensile stress and strain can be detected as it is conducted in mechanical engineering or civil engineering department, and if we put 2 copper wires on that, and we can get the say impedance across this. So if the material is a civil structure or mechanical structure or any other material apart from the biological, we can put those material across to holder, and we can put that material under the tensile strength, and strength will change the say material property, and that property will be also studied by the electrode based impedance measurement technique. So this study is also conducted by the impedance spectroscopy method. So they are measuring, continuously measuring by 2 probe method. We can see the wires are connected, and they are telling that the resistivity is also increasing with the strain. So and we can detect if the material is in online, and if we have the standard data with the laboratory measurement, we can keep it as standard data, and after that, if that similar material is there in the any field, and if we don't know about the stress strain property or anything, then we can measure simply impedance. We can measure by connecting the electrodes, and by correlating with that graph, we can tell that that type of strain is there acting on this material. So this is the concept, and from that concept, the people started working towards the imaging, because as I told, that imaging will be giving more information about the specimen. So there are several number of other electrodes, so that we can divide those the regions in a different smaller dimension, utilizing the finite element method, and utilizing the theory of electrical impedance tomography, we can get some other imaging properties also. So wherever if there is any crack, we can get that visualization. These are some other experiments where they are utilizing the copper electrodes for measurement of the impedance. Okay, so and this study started for the electrical impedance measurement, and that electrical impedance measurement is conducted through the EIT. We can see several number of electrodes are put in this concrete beam, and 3-point bending studies are done. So whenever they are giving that pressure in this point, they are visualizing the strain over here in this region, and if we put the electrode throughout the domain, we can get the region. So wherever we will put the electrodes, that will be the domain of interest. And for detecting the corrosion, also underground corrosion or any corrosion within the concrete beam or the concrete structure, we can use the same similar 4-probe technique. And if the 4-probe technique is used, we will get several number of impedance values, no images. So you can see that current is injected through the domain, and it is passing through the material. So if the current is passing through the material, definitely it will have some information, and if there is no corrosion, definitely it will have its own standard values for a particular material and material structure. And if we continuously monitor and if we record that as a standard, after some time, after several years, if we see the different values are coming, definitely there will be chances of any corrosion or any other defects. So for that, some electrical impedance data analyzer is required, so that we can get the information about the corrosion or the void. And this is the instrument which is available by the company. I have put the website here, and that type of instrument can be put on the ground, concrete road, and this is the instrument by which the fellow is detecting if there is any corrosion under the bar. And if we conduct the resistivity imaging, then we can get that type of plot also. And that type of plots will be taken by the electrical resistance tomography or electrical impedance tomography, where you can see that the more red color means it will be highly corrosive, and then whenever it will be going in the opposite direction, the color bar will tell us there will be less corrosion. So we can understand where the corrosion has created. Then other technique what I am going to discuss about that the CFRP, the carbon fiber reinforced polymer. This is another material which is used in mechanical and civil engineering for structure development. CFRP is very strong material, and its strength to weight ratio is very high, and that type of materials are developed with the carbon fiber laminates processed by the other machines where the heat treatment is given, and the material is developed with different orientation of the fiber as it is shown in here. There may be several the angle of the fibers, so that we can get different kind of mechanical property. And depending on the fiber direction, also current path will be different, and the capacitance arrangement and the resistance distribution will be different. And whenever that material will be known that this type of layer, say there will be some symmetric layer from a center, there may be several layers starting from say 4, 5 to around say even 10 layers may be there. So if we have the proper impedance profile, and if that material is under any damage, any delamination or any crack, so that type of studies are conducted during my studies in Saudi Arabia in postdoctoral studies. So we found that the impact damages are also possible to detect by impedance spectroscopy, and also the delaminations are possible to be detected. Because their delamination means there will be a lot of air void in between. So definitely the capacitance values or impedance values will be changed. Some other studies are conducted by other groups where they have put some electrodes at the periphery of a CFRP sample, and they are trying to get the impedance response to detect the delamination and cracks. And if we conduct the tomography either on the border electrodes, boundary electrodes or surface electrode, we can get any damage in this type of pictures will come. So these are the instrumentation studies, whatever instrumentation we have done for 32 electrode system, because 32 electrode system will be more sensitive and there will be more number of data. So the algorithm will get a sufficient number of known variables to get the solution for the unknown variables. And this instrument will be manual instrument, so that we can switch any electrode by the manual effort. And after that we went for the 32 electrode based system for the automatic electrode switching, where you can develop some multiplexer board for switching the electrodes. And these are the instrumentation which are used from National Instrument. And the computational program is studied, how the data will be collected. And we pasted the ECG electrodes on the surface of the periphery, and we collected the data from the CFRP sample. So as a conclusion, I can tell that EIS is a material characterization technique, and EIT is fast and low cost and portable CT technique. EIS and EIT can be utilized for studying the different types of materials, and EIS and EIT can be used for studying the biological, non-biological and other materials also, food, vegetables and meal. All, and EIS EIT can also be studied by civil engineering material characterizations. A number of research opportunities are still there, because there are sometimes the results are not very clear to detect between the say air void or some other kind of crack, means whether it is void is created due to the constructional time or the void is created due to the crack. So though it is not possible through the impedance spectroscopy measurement, but it is possible to detect from the resistivity imaging or impedance imaging, because the creation of void profile sometimes may give some information, but still more studies are required to detect those type of damages. Either it is damages due to the construction or due to the effect of extra loading, or that is the creation of crack. So I want to acknowledge my supervisor and postdoctoral supervisor. I acknowledge Dr. Vijaya, Professor Vijaya, to giving me the opportunity for presenting the research work. And I thank the Gayatri Vidya Parishad College of Degree and PG course. Thank the Department of Civil Engineering, and I thank all the faculty members and organizing committee members for the FDP, and I thank all the participants for listening my talk.
Thank you, Professor.
Thank you very much.
I request the participants to ask any questions that they want to. Sir, there is a small question I would like to ask.
Yes,
if
yes.
Anybody would like to. Yeah. Sir, for structural members monitoring, the equipment that is used, the instruments that they use, are they commercially available, or do you have any photographs or techniques of using instruments?
Yeah. Actually, I showed few components here. So I have developed that instrument. It is visible?
Right now, no, sir.
It's not visible?
No, sir.
But it is.
Are you screen sharing?
Yeah, I'm in the screen sharing. Okay, I will go to the.
Now we can see it.
Okay. So I will show another. Now you can see any screen?
Yes.
Okay. So this is the system. Actually, I wanted to discuss about EIT. So due to the time, actually I could not. So this is the circuit what I developed during my PhD. For we can see that how the data is collected. So switching of the electrodes are made in this way, and so that we can get the data from the phantom. So this phantom is now the saline phantom. We can put any concrete block here, and after keeping the electrodes around the concrete block, and we can get that. So like that we can use that instrument. That instrument is developed by my PhD work, and after that we developed this work during my postdoctoral research. Similar instrument, but it is earlier it was for biomedical. This is for mechanical and aerospace engineering applications. And my other postdoctoral group was working on civil structure monitoring with the concrete beams and all. But instruments are similar. Instruments are available also. Those which are available, that is not especially for mentioning that civil impedance tomograph, but it is possible to apply that instrument for the civil engineering applications also. Just tuning the frequency. If we want to apply the 15 megahertz, then our instruments should have that capability for injecting current at that high frequency. And the frequency whatever I have developed, that is suitable for injecting say 10 megahertz voltage signal and 2 megahertz current signal. Hello.
Yes, sir. Thank you, sir.
Yes. So the study whatever I have shown in the literature survey, that is they went for the 15 megahertz. So our instrument whatever we developed, that was able to go up to 10 megahertz for voltage signal.
So the data generated by this instrument is connected to your laptop, and from which you will analyze it, sir?
Yes.
Do you use any specific software for the data analysis?
Yes, we used MATLAB for writing the impedance tomography code, and that is EIT code, and we used LabVIEW for EIS.
I see.
because LabVIEW is signal processing, so we need to interpret the curves. So LabVIEW based software I developed, and for the impedance imaging technique, we used the MATLAB for developing the image reconstruction software. And some software are also freely available in website. Some software are also freely available in website.
Sir, are these instruments commercially available in India or?
Not in India. We have to buy from US or any other country. So those instruments are there, impedance analyzer, and from I am telling from the companies also, impedance analyzers are there from the Keysight. Earlier it was Agilent. So impedance analyzer from Keysights are there. They are selling the impedance analyzer in till several megahertz and gigahertz also. So those instruments will be suitable for civil material characterization.
I see. Anybody would like to ask questions? Please go ahead. Sir, have you also patented your instrument, sir?
No, actually we are in the process, but it is not done yet. So when I was doing in IISc, so I tried to do that, but due to several works, I had to go for the postdoc and all. So I left the institute and it is not done.
Sir, in the previous sessions of our building information modeling, yesterday and day before and today also, they have shown the integration of several professionals as an integrated project delivery for newly constructed structures. Your topic is probably will connect to existing structures and their structural analysis of existing structures. So, have you had any experience in integrating your technology into any BIM project, sir?
Not yet. I have done any civil engineering project. I have not applied that thing, but I have a plan to develop the system, particularly for civil, for the water content measurement for the brick wall. So in that I am in the process, and I am studying regarding that. There are several works conducted on the water or moisture absorption detection in brick wall, because brick wall will be absorbing water wherever the moisture is more, and if the roof is not having proper say material or proper structure, then water may be stack inside that, and from there water may enter to the brick wall and as well as in the roof. So those concrete structure property will be changed, because water will be damaging the wall, and it will be very, very dangerous for the RCC, because there will be several say iron bars, and if moisture is there, that may be corrode. So that type of project I am planning to do that, and also I am collaborating with the civil department here and writing one project, but till now that project not yet started.
In fact, that's a very coincidence that you mentioned it, sir. Very recently, we had a meeting with one of our senior advisors who suggested that is there any technology or machinery that can detect water content in existing brick walls. So we were just brainstorming on what kind of a project can we do to encourage this, and we train ourselves in detecting it, because building structure will last 50 to 60 years, and if left to itself, it will probably be left to use for 100 years.
Yes, yes, I understand. Madam, your voice is not coming.
Quality of construction cannot be predicted after it
Yes.
has been constructed. So there was a discussion about this, sir. It's very coincidental that you mentioned it.
Yes, yes,
We'd
yes.
like to tie up with you, sir, if we can test it. I mean, train ourselves using your non-patented equipment without getting an electrical shock.
Yeah. No, 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 no. It is only sending 1 milliampere. I am only sending
Oh,
1 milliampere. So till 30 milliampere you can go
I see.
without any feelings. Means it will not be even understood that something is entering to the object.
So you will be putting these electrodes to a wall on both sides of a
Yes,
wall, and it
yes,
will tell us the water
yes,
percentage. Wow,
yes,
that's
yes,
excellent.
yes. That can be done. Yes, that is
That
my
is
actually.
excellent.
Yes.
Excellent. Excellent. In the master's MTech structures programs, there is a particular course for repair and rehabilitation of existing structures, which
Mm-hmm.
spans not only modern buildings, including ancient buildings, including temples, because that is the future for one set of professionals who work on
Yes, yes, yes,
maintenance.
yes. Yes, maintenance is very, very important in our civilization.
Yes.
and
Yes.
and we have found so many unfortunate news that flyover is broken, that bridge is broken, and so many lives are lost. So this is very unfortunate. If we have some that type of low cost, portable and fast technology which can be conducted with very minimum expenditure, then it will be very good for us. So I am working in this area, though civil is not my field, but still I have a big interest in civil. Even honestly, I am telling that I was also during my joint entrance, I was trying to go into the architecture. I cracked that examination also. So after that, I got the electrical and I shifted to the electrical department. Anyway, so the application is many for the electrical technique. So that's why I have already worked in the aerospace in Saudi Arabia in mechanical engineering department. Aerospace material I have tested, and after studying the biological material during my PhD. So now I am shifting towards other fields so that I can get some more knowledge and I can contribute my expertise in that field. And I have plenty of plans for mechanical and civil engineering materials detection. And one project, as I told, that I am writing on that. Definitely, if you are interested, we can collaborate for writing any other suitable project as you mentioned. So, so
That
this
will
is the
be
start. Yes, that will be this is the starting point. So we can work more in future, definitely. And other thing that the technique is very much fast, and it is very portable. Means we can take that material, take that instrument anywhere. We can have it as a very portable and handy device, and we can take it anywhere for testing. So that is a very big advantage for that.
Yes, sir. Excellent,
Yes.
yeah, excellent technology.
Yes.
As far as the participants today, they're all listening to lectures on the building information modeling, and if you, as you are aware, building information modeling is more for new projects. But
Yes.
I
Yes.
think the scope of BIM will start expanding for maintenance of existing structures. Let us say we are looking at Burj Khalifa and it is already inaugurated, occupied, and 10 years down the lane, I mean, there is constant maintenance, but structural strength, like you said, humidity presence in structural members or in brick walls or in glass frames, if we can use this technology, I think BIM will start expanding for maintenance and repairs and rehabilitation of structures too. So that
Yes.
will be
Yes.
a
Yes.
very
Yes.
nice
Yes.
avenue
Yes,
to
and
extend.
in our institute, I am also offering. I have not yet started. I have proposed already one course because we need to develop some new course which will be very much relevant to the society, as well as it will be having some scope to contribute to the society. So I developed one course called non-destructive testing. So that may be testing say civil, mechanical, electrical, those core engineering devices, core engineering materials. So there are several techniques, as I mentioned, that X-ray based or ultrasound based, electromagnetic, electrical. So I will be covering and teaching all the review reports of that. So that will be also good for say discussion. So if we after the COVID, if we meet, then we can discuss about that. So I think if I discuss some other techniques also which are there still there, and with you, so with your expertise in civil engineering material, I think it will be very good to get some new direction for some collaborative projects.
Yes, sir. Yes, sir. Any other questions from participants? Please go ahead. We are almost towards the end of the time. We have 10 more minutes to go.
Yes.
We'll be definitely in touch, sir. Gayatri Vidya Parishad would like to collaborate.
Yeah. Thanks.
Because this is one of the ideas suggested recently, very recently, so it is still fresh in our minds.
Yeah, that will be very good because say where actually in most of the time I stayed in the rented house and I found that they are in very bad condition, lack of monitoring, and so I thought the idea came in my mind long back that how that could be say solved, means that type of inspection must be there, otherwise it may be dangerous, and even the life of the building, as you mentioned, madam, so it will be less. Otherwise we can enhance the life of any construction.
Yes. We
Yes.
all have to be concerned about the cost of a structure. When we build it, we are spending crores of rupees on making expansive buildings. Nowadays, the individual house construction has expanded into apartments, into gated communities, large campuses, not only residential, non-residential, commercial, high-rise. So we have to protect these structures because the investment is very high. Once the construction is completed and it is occupied, there has to be maintenance and possibilities of repair so we can extend the lifespan.
Yes.
If there are no further questions, I will close the session a few minutes early today. Thank you so much, sir. Tushar sir, for
Thank you, madam. Thank you, madam.
bringing your expertise. We are so grateful because there is so much happening in the and then interdisciplinary levels. When we all sit together of different professionals, we still have so much to learn from one another. You brought this new technique to us. We only heard about it or have thought about it probably. And we can see that you are already experimenting, so it's so heartening to see your work, sir.
Yes. Actually, when I was in South Korea, so my other group was working on the concrete crack detection. So I participated, but I was not involved much in that field because I was studying the biomedical part. So, but still I was a part of that group. So I saw they are developing the concrete structure and they are developing. So I have the long back interest so that I can also develop my own laboratory setup for detecting some material which will be coming from civil, mechanical and aerospace. So I got second postdoc in aerospace material, so I was happy. But now I am waiting for a collaborator so that because developing civil structure and doing everything by my own, it is very difficult. It is not say good also. Nowadays, if we go for collaborative research, it will be fast and even lot of brain will be working, means the quality of the work will be very good. So that is the beautiful thing in the multidisciplinary work. So I I am very open to the collaborators. I already in the NIT Durgapur, so I have the civil engineering department. But if some other institutes are interested, we are happy to collaborate with that. So that's why I saw that so those papers, and I collected and I studied and I just correlating and planning and writing. So definitely we can do much very quickly.
Sir, does the civil engineering department in your university and in your NIT have this structural monitoring capacities? Are they doing projects on it?
There are a few laboratories are there, but in which area they are working, that it is not good to means tell. Say there may be research or some public ideas will be there. So
Ah,
I am also not very much aware also. So they are working on structure, even in non-destructive testing also they are doing. But in
acha.
which field they are working, uh, particularly I am not sure. And also few things I know because I discussed, but as I heard from the faculty, so it will not be good to discuss in the open platform. So whenever we will make any meeting and we will be working or discussing together, I think that will be good to discuss
Yes, yes.
with the
Sure.
presence of that faculty, means the other
Yes.
faculty will be there. So whenever he
Yes.
will be there with us, definitely we will discuss. So as he is not present in this meeting, so I don't like to discuss regarding his say work like that.
Yeah. Yes, sir. Totally understand.
Thank you, ma'am.
Thank you so much, sir, for bringing this innovative methods and machinery, which we are very new. I mean, for me, it is new. We only heard about and thought about, and actually knew that this was there in other countries. Um, but we are so fortunate to have you amongst us today. Thanks for your time and then volunteering to come to our platform. That was very nice of you, sir.
Thank you very much.
Thank you, sir. We
Thank you.
have a good day. We'll be in
Thank
touch with you, sir.
Yes, definitely. We will be love to collaborate with your institute. So please contact us and we can make a good plan for the scientific project.
Thank you, sir.
Thank you very much. Thank you. So I
Thank you.
can log out from the system.
Yes, sir.
Okay, okay. Thank you.